factors that we're given in Circly, but using Excel. Okay? It says we're going to design it for our critical layer, and we can use the supply template. Okay? So this is what we're going to do. So let's say we've done pavement 3B. Okay, and we get an output that looks something like this. Okay? So we get this. Your design could look different. Okay? This is how mine looks. And I get 3 different CDF values, okay? A CDF for AC10M, 14M, or 20M, sorry, and subgrade, okay? Now we're going to perform the calculation in Excel for our critical layer. So what would our critical layer be here? AC10M, yeah? Why, do you think? Because it's close to 1, right? So the value, the AC layer that's closest to 1 will be our critical asphalt layer. So once you've designed pavement 3B, okay, the first thing you need to do is identify your asphalt layer, critical asphalt layer. So in this case, I'm going to perform the calculation on Excel for my AC10M layer. Make sense? You guys may have some different numbers, and obviously what happens is, if I perform the calculation for AC20M or 10M, it's going to be different. Okay? So I need to find where my critical layer is and then perform the calculation for that layer. Okay? So this is what the spreadsheet looks like. Okay? We have some input parameters here. So the first thing we need to put into the spreadsheet is NDT. So we calculated that in week 1, remember? And then the next thing, the constant, the shift factor, and the reliability factor. Okay? So depending on which type of asphalt material we're doing the calculation for, we're going to put in that constant. Okay? If we're doing the calculation for AC14M, we put in the constant for AC14M. Okay? And then shift factor and reliability factor, we talked a little bit about last week. So remember the shift factor for all materials, we use 6. Okay? And the reliability factor we could get from remember the reliability factor we could get if we knew the project reliability. Okay, so in our assignment it said the project reliability of 95%, therefore our reliability factor for asphalt could be 6. Okay, so there's some important material parameters to set up the spreadsheet. The other 2 that I didn't talk about are the strain. Okay, the strain under SAST, so a single axle single tyre, and the strain under a SADT. Okay, 2 types of strain measurements. We'll talk about that in a few slides' time, what they are, what they mean. Okay, so that's how you set up the spreadsheet, and then obviously the next thing that you need is your traffic load distribution. So you're going to paste your traffic load distribution in here. Okay, remember in week 1 you were given a group number, and depending on that group number, you had your own traffic load distribution. Okay, so you're going to paste that in there. Pretty much there's 4 steps to do this spreadsheet. We'll go through each of them now. Okay. So what I'm going to do is first, let me get my traffic load distribution from the tab. Okay, so I'm going to download my traffic load distribution, and that's how we can start the problem. So let's let's say I was group 12, so I'm going to paste my traffic load distribution in here.
What?
Okay?
The spiders in Australia are the most.
So pretty much what we need to do is we're obviously calculating CDF, and we talked about last week to calculate CDF, we needed two numbers, right? We needed two n's. What CDF does, it compares two n values, the number of expected heavy vehicle axle groups, okay, versus the number of heavy vehicle axle groups until fatigue occurs. So if we compare the two, okay, n, the expected cycles, versus n, the allowable cycles, we get CDF. So ultimately, what we're going to be doing in our spreadsheet is working towards calculating those two n values. So the first step would be to calculate the expected cycles, okay, of each axle group. So what you can see in our traffic load distribution, okay, you would have talked, well, Rajapal would have talked about this in the first week. He said 0.0046 of a proportion of 1 in our traffic load distribution is SAST carrying 10 kilonewtons, right? We discussed how we can read the traffic load distribution, okay? But what that traffic load distribution doesn't tell us is how many times a SAST carrying 10 kilonewtons is going to pass throughout that entire 25-year design period. It doesn't tell us that, okay? So the first step that we're going to do here is calculate that. The expected repetition of, say, a SAST carrying 10 kilonewtons, okay? Or the expected repetition of a TADT carrying 20 kilonewtons over that 20-year design period, okay? So step one is all about finding the expected repetition of each axle group carrying each different type of load. So how do we do that? Well, if we know our NDT, we can do that. So let's say my NDT was a million, okay? So the first step, what I'm going to do is I'm going to fill in this table, or these tables, along here. So you can see we have a table for SAST here, a table for SADT here, and so forth. So we have a table for each axle group, okay? So what I'm going to do is, here I've got all my loads, okay? And I've got my design traffic. So my NDT, let's say that number, okay? Don't worry about these numbers, we can put them as one. We remember in our traffic load distribution, if we added all these numbers together, okay, we get 1, okay? So where it says proportion of axle groups, we know from the first week that this number is 1. If we add all these axle groups together, it comes to 1. So as I was saying before, this is 0.00046 out of 1. So proportion would be 1, okay? Sorry, this number here is going to be our real proportion. So it's 0.046 out of 1, okay? So if I want to find